Hello everyone. Today we want to review polar coordinates. Now, we start with a point called the pole, which basically is the origin on the xy plane, and then the positive x-axis is a ray coming out of the pole. Then all points are measured as the distance to the pole, which we will call r, and the angle made with the pole, which we'll call theta. So if I put that on the xy plane, then that gives the picture for any point xy on the xy plane. We have a right triangle here, such that if that's r, then r squared equals x squared plus y squared, and the tangent of theta equals y over x. Further, our SOHCAHTOA relationship here tells us that x equals r times the cosine of theta, and y equals r times the sine of theta, which you probably remember from previous courses. So if I wanted to do a simple problem, let's say where I wanted to go from rectangular coordinates to polar coordinates, let's take something simple like a vertical line, the line x equals 4. I want to write this in polar coordinates, which means I'd like to write it as r equals if possible. So if I change x to r cos theta equals 4, and then I multiply both sides by the reciprocal of the cosine, I will get r equals 4 times the secant of theta. So that's a simple way of describing a vertical line using polar. Now, what about the circle x squared plus y squared equals 16? I know that's a circle centered at the origin. So if I want to write that one in polar coordinates, first of all, I notice the left side is simply r squared. So if r squared equals 16, then r equals 4. We don't say plus or minus 4 in this case because r is measuring the distance to the pole, so we will keep it as a positive value here. Now let's look at an example where we want to go from polar to rectangular. Now in this current form, it will be difficult to substitute back into x and y because I really need an r cosine and I'd really like an r squared. In order to do that, I would need to multiply both sides of this equation by r. But remember, the basic rule is you can never multiply by a quantity that can be 0 unless 0 is already a solution. Meaning, are there values of theta where r already equals 0? Well, I notice if theta equals pi over 2, then r would be 0. So r equals 0 is already a solution, so it's legal for me to multiply both sides by r. In doing so, I'll get r squared equals 6r cos theta, which now makes this simple to substitute. So I would get x squared plus y squared equals 6 times x. And now if we complete the square, we'll get x squared minus 6x plus y squared equals 0. This will be x minus 3 squared, half of that number, so I will add 9 to both sides. And now I have x minus 3 quantity squared plus y squared equals 9. We recognize that as a circle of radius 3 with center 3, 0. So if I were to sketch that really quickly, basically it would be a circle that looks something like this. Right? Now we'd like to sketch a graph in polar coordinates, particularly r equals 4 plus 4 sine theta. Now what I've created here is what's called a polar graph, or basically polar paper. This is a ring of radius 2, 4, 6, 8. On the xy plane I've superimposed, the vertical line would be an angle of pi over 2, the horizontal line 0 in pi, and then I did 30-degree lines for pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 because those are friendly values for the sine. So if I said, let's make a table of values, that's the simplest way to go about it. When theta is 0, sine of 0 is 0, so I would get 4. Sine of pi over 6 is a half, so 4 plus 4 times a half would be 6. Sine of pi over 2 is 1, so 4 plus 4 times 1. Sine of 5 pi over 6 is a half, and sine of pi being 0, we're back to 4. Now sine of 7 pi over 6 is negative a half, so this would give us 2. Sine of 3 pi over 2 is negative 1, so this would give us 0. 11 pi over 6, we'd be back to 2, and 2 pi, we'd be back to 4. So if I said, let's put these values on our polar graph, then an angle of 0 means I'm on that ray right there. So if that's 2 and that's 4, be here. Pi over 6, I'd be 6 units. At pi over 2, I'd be 8 units. At 5 pi over 6, I'd be at 6 units. At pi, I'd be back to 4 units. At 7 pi over 6, I'd be all the way to 2 units. And now I'm back to the origin. And then here I'm at 2 units, and then back to 4. So if I said, well, exactly what does this look like? Essentially, we have something that looks kind of like this. So if you recognize in the black, that's basically the heart shape, or what we call a cardioid. Okay? So the simplest way to look at this would be to draw it. Now, if I said I want to make this into a rectangular equation, well, that would be quite complicated. Because if I wanted to do a rectangular equation, first thing I would need to do is multiply both sides by r. We know r equals 0 is a solution. So if I multiplied both sides by r, I'd get r squared equals 4r plus 4r sine theta, which would give us the simple equation in the xy plane of x squared plus y squared equals 4 times the square root of x squared plus y squared plus 4y, which would not be very friendly to work with.